Okay, now we've looked at the introductory talks in the anatomy. We've looked at osteology, myology, neurology and arthrology. We're now going to look at the bones that are associated with the hip region in particular. So we're going to start looking at the vertebral column. We're going to have a brief introduction to the vertebral column. We're going to look at the pelvis, and then we're going to look at the femur itself. The vertebral column is a stack of bones made up of a total of 33 vertebrae. Each individual vertebra is identified by a letter, which denotes the region that it is found in, and a number, which denotes its relative position within that region. The cervical spine, which are the bones of the neck, as can be seen up here, these ones here, are normally 7 in number. And so the highest one is C1, then C2, C3, all the way down to C7. The thoracic region, these are vertebrae that articulate with ribs. So the ribs themselves come round, and the first rib will articulate with the first thoracic vertebra, so T1. The 12th rib down here will articulate with the 12th thoracic vertebra, T12. So these are T1 all the way down to T12. Below that, we have the lumbar spine. And the lumbar vertebrae are 5, so it's L1, 12, 5. And at the very bottom, we have this bone here, which is the sacrum. Now, the sacrum in a mature adult is made up of 5 fused vertebrae, or typically 5 fused vertebrae. But these can be identified as S1 through to S5. Below the sacrum, we have a redundant tailbone. This is the coccyx. Now, the coccyx, or the coccygeal vertebra, number anywhere between 4 and 5. This is a mobile tailbone, and its primary function is for the attachment of ligamentous and muscular structures. Although these are the typical numbers of vertebrae, 7 cervical, 12 thoracic, 5 lumbar, 5 sacral, and 4 or 5 coccygeal. Occasionally, we get anomalies. The commonest anomaly that clinicians may come across is a 6th lumbar vertebra. And occasionally we see the lumbar vertebra itself, the 5th lumbar vertebra, may fuse with the first sacral vertebra, and that's known as a sacralized L5. Or the first sacral vertebra may not fuse with the second sacral vertebra, and so we have a lumbarized S1. And these are anatomical variations that clinically become important because it changes the mobility of the lumbar region. Between each vertebra is an intervertebral disc. The only exception to that is between C1 and C2. There is no intervertebral disc between C1 and C2. The embryologically there would be, but that fuses quite early on in life to form a bony process known as the odontoid peg. Also, between S1 and S5, there are no visible intervertebral discs in the mature adults, because as the vertebrae themselves fuse, the intervertebral discs become bony. But between C2 right down to the top of S1, you will find an intervertebral disc. And this is a fibrocartilaginous structure. It's like a piece of rubber almost that's got fluid in the middle that attaches one vertebra to its neighbour. The function of the intervertebral disc is partly for shock absorbency. It keeps the vertebrae themselves apart. It gives the vertebral motion segment a bit of height. It provides stability between adjacent vertebrae as well, while still permitting a small amount of motion. All typical vertebrae share some common characteristics. C1 and C2 are not typical vertebrae. Anteriorly, there is a cylinder of bone. This is known as the vertebral body. And this is found actually inside the body. We can't palpate the vertebral body because it's too deep. So there's our vertebral body. And these are cylinders of bone stacked on top of each other. These are the main weight-bearing sections of bone, and the vertebral body itself is formed by a small layer or a relatively thin layer of compact bone externally and a significant amount of trabecular bone internally. Behind the vertebral body, we have this section here. This is known as the vertebral arch. Okay, and there are a number of processes associated with the vertebral arch. There are significant variations in the size and the shape of both the vertebral body and the vertebral arch. The lower down you go, because there is more weight bearing and more stress going through the spine, we find that the vertebral body is significantly larger and also slightly different shape. Behind the vertebral body we have the vertebral arch, and the vertebral arch is made up of a number of processes. Firstly, we have two pedicles, and the pedicles are these processes of bone that attach the vertebral arch to the posterior aspect of the vertebral body. Between adjacent vertebrae exits the nerve root, so we'll have one nerve root. So within the vertebral canal itself we have the spinal cord in here, and we'll have a nerve root exiting on one side and a nerve root exiting on the other side. And the nerve root exits between adjacent pedicles. The pedicles above and below are notched, so they form a hole known as the intervertebral foramen, and that's for the exit of the nerve roots themselves. Behind the pedicles, we have two processes that are orientated obliquely inwards. The lamina, the right and the left lamina here. And the point at which the lamina join, we have a process known as the spinous process that projects backwards, projects posteriorly. It's the tip of the spinous process that we can feel under our skin when we feel our back. That's the only clearly palpable part of the vertebral column. The rest of the vertebral column tends to be buried underneath muscle, which we can work our way through to actually get to. So we can get our fingers on the transverse processes, on the articular processes here, transverse processes here. But at the spinous processes essentially sit subcutaneously. At the junction of each pedicle and each lamina, we have three processes. We have the transverse process here, and these are like little wings, they're little levers for the attachment of ligaments and muscles for spinal movement and spinal stability. We then also have articular process. So there's one articular process here projecting upwards, and on the underside of this vertebra we'll have another articular process. Accurate palpation of spinous processes becomes important. The palpation of spinous process orientates us in the spine, and we can identify whereabouts we are in the spine by the shape and position and movement of certain spinous processes. At the base of the spine we have the sacrum, and the sacrum is made up of 5 fused vertebrae, S1 and S2. It forms the base of the spine, a stable base to the spine, and it is the point of attachment between the spine itself and the innominate bones to form the pelvis. Here we see the anterior surface of the sacrum. So there, that would be S1, S2, S3, S4, and down here is S5, and in between we see these ridges, these bony ridges. These are where the discs would have been had the 5 sacral vertebrae not fused. These processes here, this section of the spine here, are these are known as the alar of the sacrum, the alar of the sacrum, and they are formed by the fusion of the transverse processes and the costal element of the sacral vertebrae. So they form one lateral bony mass here and a lateral bony mass there, and it's on the lateral aspect of the two alar that we see this articular surface here known as the auricular surface. The sacrum can be palpated. The central portion of the sacrum, where the original spinous processes would have been, again, these are fused into a central ridge. This section here, this can be palpated at the base of the spine, coming down between the crease between the buttocks.